Yeah, today we are going to talk about pitfalls in performance. So, like Lalit alluded to, uh, from the very beginning, I was interested in all things performance. I started out as an engineer at heart, but increasingly got sucked into this vortex of performance engineering. I say sucked into like it's a bad thing, but no, I absolutely enjoy it. But a lot of the failure stories I'm going to share are coming through this experience. So, before college, I got into a lot of UI design and designing websites. And during college, to just earn spending money on the side, I started doing backend development work. And as you can imagine, this is without any experience. So all of this time is just failures nonstop, one after the other. We have a complete conference about all the failures during this time, but that's not the point. But as I started working professionally, uh, I started working formally on performance testing, and all the mistakes I had made back then started to make more sense as I started to realize what are things to avoid and what are things to do. And over the last 10-ish years, I've been focused more on performance engineering. We'll see the difference, sorts why I call testing different from engineering, but across different continents, across multiple clients, seen a lot of different things that you can do incorrectly. And with performance, your failures are broadcast to the entire world. When your site goes down or something of that nature, everyone knows. It's on Twitter, it's on Facebook, you get free publicity, not of the good kind. All right, so let's jump right in. Before we jump into the stories, just want to make sure setting the context for all of us to be on a similar page to focus on what is the area that we're talking about. At a high level, all things dealing with performance, which is the latency and utilization characteristics of systems under different types of load. We all know that at a high level as the umbrella term of performance, which has different types of testing under it, load, stress, etc. But two new properties that are emerging for systems, especially in the modern world with microservices and uh, serverless functions and units being broken down smaller and smaller, scalability and resiliency are becoming equally important characteristics, where scalability is the ability of the system to grow along with the load while it is being provided additional resources. Whereas resiliency is the characteristic or the ability of the system to maintain its performance characteristics when underlying components of the system start failing. And in all of our organizations and projects that we might have worked on, at a high level, we kind of know why performance testing happens. It's either to make better decisions when you're comparing two different ideas, to see which one performs better, what is the path you need to take. For release confidence, your regular releases, you do regression testing to make sure nothing has gone horribly wrong so that your customers don't have an bad experience when new release goes out. For capacity planning, to make sure that we are set up for the future as our traffic grows month over month or year over year. Especially for busy times, like let's say you're a retail website and there's some shopping holiday coming up. You That's the time that your website or your system needs to be up and be able to take in all that money that's coming in. There are a lot of industries that need compliance as well, from both functional and performance perspective, like healthcare, banking, and overall for retention or conversion. You want to keep your users, you want to keep your customers and clients, and performance is one of the reasons why they might be walking away. All right, with that, let's jump into our first story. Uh, Earlier, I was thinking about putting in a lot of different stories and spending a lot of time with them because They're very interesting to me personally. But I thought let's keep the story small, but focus on the learning from it. So I'll just quickly give a high level overview. Again, I also don't want to name names. Uh, I'll just call the customers a large grocery chain in Europe. They had invested a ton in performance testing projects. And it's not that they were ignoring it by any means, which does happen quite a lot, which is a failure in itself. But even after a significant amount of investment in having dedicated performance test engineers and running performance test cycles, they still saw that they had gigantic meltdowns for their applications in production. So that doesn't jive, right? That doesn't add up. Like if you are making investments, you should be getting some results or returns from it. So what happened? What happened was folks were not really paying attention to why they were doing the things that they were doing. For example, uh, there were different teams that were running optimization or tuning tests, A/B tests. There were teams that were running capacity tests to understand what the capacity of their subsystem is going to be. There were teams that just had a very simple regression test running. There were some teams that were customer facing that had competition and were doing benchmarking tests to show this is where we stack up. At a high level to the executives, the picture looked like, oh, we have so much performance testing going on all across the board. But there wasn't a clear rhyme or reason as to when a release is going out. What are the different things that you need to pay attention to before you can sign off on it? Just the presence of performance testing is not enough. And I call that out specifically for performance testing because as performance engineers, we have the extraordinary ability to waste everyone's time. We could be running the wrong test that leads to false overconfidence, meaning just running a test for the sake of running it. On paper, it looks like, yeah, we ran performance tests, good. Other companies or other teams don't even run it. And you get this false sense of security that we are good, and then you go and fall flat in production. Or we could also be chasing demons that don't really exist in the real world and be wasting people's time like that. Meaning, everyone is ambitious, everyone wants more users on their system, but to come out and say, we are going to test our system to make sure that it can support 7 billion people, because there are 7 billion humans on the planet, and we want everyone to use our system. That's not a good use of anyone's time. You're not going to have 7 billion people on your system at any given time. So those are the extreme examples of how one could waste time. But that brings me to the main learning from this story, which is targets and knowing the right terminology around targets. So there's a lot of confusion overall regarding a few of the terms. So I wanted to call these out. That setting these out from the beginning and getting everyone on the same page has helped prevent some of the.
Kaushal, we lost your sound. I'm sorry. No. Sure, take your time.
Hey, how about now?
Back.
Good.
You need to just share your presentation again.
All right. Let's do that. How about now? Is this better?
Yeah, but you probably need to pull your presentation in the shared screen.
What are you seeing right now?
We are seeing our uh, panel here.
Oh,
Yeah, now I see. Yes, perfect. We see
and
your
let me swap
presentation
this
with
here.
perhaps.
Yeah,
Perfect.
this should be
Okay.
better. Let me rearrange a few windows quickly. Sorry about that.
No worries.
Okay. All right. Back on track. Cool. Yeah. So I was talking about functional requirements versus non-functional requirements. And functional requirements, I think pretty much everyone has a very solid grasp on them right now. Non-functional requirements, maybe 10 years back, were very, very nebulous. The picture is getting better, but you'd still be hard pressed to find very good non-functional requirements provided clearly for a project. So one of the ways to think about that is to take in some of the terminology that Google has put out around SLAs and SLOs. Uh, an SLA is a service level agreement. The A part is important there, the agreement part, because that makes it a commitment between two parties, a service provider and a client. And there might be penalties associated with that, that if you do not meet these terms, then there might be monetary penalties, or you might have to give discount points, or the contract may be null and void. But that's where the A part takes on importance, that the agreement exists and there will be consequences if the agreement is not met. Compare that to an SLO, an objective. An objective does not necessarily have any kind of agreement, it's just something to aim towards, typically for an internal team, to say, we want our response times at the 99th percentile to be under 2 seconds. Uh, and that's just an objective. If we don't meet it, we will have some internal policies on figuring out what we need to do next, but we are not going to hit customer penalties or anything like that. And service level indicators, which are the indicators that show what is the current level of service that you're achieving either in test or in production. So these are your counters or your monitors that show this is what your utilization rates are, or this is what your response times or error rates are. So how do we bring this all together? So you start with your SLOs or SLAs. Again, the A being the agreement between the two parties, O being just an objective that you set for yourself. And you drive that into your non-functional requirement such that it becomes the definition of done, that you cannot call the work product complete until you have met and tested for this non-functional requirement. And once you have tested for it in the lab, by also making sure that you have good service level indicators that you have put out and you're monitoring it both in the lab and in production, to make sure that your results are not just true in the lab but anything goes in production. Correct. So that was the first story and the high level learnings from it. Let's jump into story number two. And again, not going to spend too much time on the story, want to spend a little more time on the learning. So this was a very large telecom operator in the land down under, and they had a decent investment in both performance testing, and they had just onboarded a very expensive monitoring tool and utility. And the shift in the industry was, let's do little less of pre-work in performance testing engineering activities. If we have the uh, best in the world monitoring system, we will be able to spot problems quickly and resolve them. Uh, and that way we don't have to spend a lot of time upfront We can just push to production quickly, observe if there are issues, and fix, roll back or fix as needed. But what started happening was they got all these expensive tools. They were used by teams that did not really know how to use them. So a few different, again, lot of meltdowns and failures because of having everything there but not knowing how to use it. And some of the learnings that I was able to extract from that were you need to know what it is that you're looking at when you're monitoring. Performance is not one single number. Performance is not a pass or a fail overall that answers all different situations. And especially your math basics need to be a little solid and know what you're comparing to. Averages are, in my book, a really bad word in the performance world. May it be mean, median, or mode. When you're taking uh, things like response times and converting that to an average, you're really losing out on a lot of the information because these types of numbers have a lot of outliers. You can have 90% of your data look exactly the same, but you'll have 1 or 2% of your transactions or response times be way out there, maybe either too good or too bad, and that's going to make your average completely meaningless. Because with every big outlier, it's going to cause massive shifts in your average. So you can't really rely upon averages, not just in response times, but in utilizations, failure rates, etc. A good way to think about it is percentiles, at least for uh, some of the high level metrics. A percentile is a much more robust and standard measurement for response times because even with outliers, it's not going to budge as much. Your 99th percentile, 95th, 90th, if you can describe your latencies and response times in those percentile numbers, you can be fairly confident that a few outliers here or there are not going to budge it. And taking it to the next step, if you are able to understand distributions, I used to think in college, where in heaven's name am I ever going to use uh, all this math that I'm learning? Like, especially with binomial distributions and normal distributions, uniform, long tail. I thought all of that was useless information. But if you do apply it to all the, when you run a performance test, it just is a barrage of numbers that is coming at you. Your tools try their level best to make it easy for you to consume and to be able to understand what's happening because it can't show you 1 million numbers at the same time. But if the tool does a not good enough job of summarizing that number for you, you may have done everything right, but you still might not be putting out the right results and not forming the right conclusions. So, getting to the base and working with the numbers yourself uh, can bring out some of the things that the tools are hiding. So, with that monitoring story, uh, there were again tons of failures across the board. Some of the do's and don'ts that came out of it were that monitoring is not a silver bullet. It, and again, people thought we got the best tool, and now that we have the best tool, we should not have any problems. So they were very tool focused and tool oriented. And running after a tool or replacing a tool, it's just a never ending cycle because there's going to be new tools that have other functionalities. It's also not a job that we have this set of people or this team. We have set up the best tool in the world for them. Now their job is to monitor and let us know if there are any problems. There are cases where a knock type of functionality, where there's a dedicated team sitting in a room surrounded by monitors. Yes, there is a place for that. But in regular development teams, for a team to not know what is going on for them in production and rely on someone else to tell them, it's not going to inculcate all the learnings that are coming out into the team's processes. Also, it's not a checkbox that, oh, we have a tool, now let's add monitoring and alerts on everything. and anything that we see, because it's just going to generate a ton of alerts that after 2 days everyone is going to start ignoring. People will create Outlook rules and it will go straight into the bin. If there is no automation in deploying monitoring solutions, it's going to be forgotten very quickly. Also, when you have a lot of these tools and they're just throwing a ton of information at you and you don't know what to do, sometimes the best place to start is from the user perspective. Start as close to the user as possible. Instead of, there are 800 different signals that a Linux machine can provide at the very base level around CPU, memory, disk, network, and it might be very difficult to correlate what's happening with those low level underlying signals. If you start at the high level, this is what my users are experiencing, and then work your way backwards to what might be the root cause of why my users are experiencing this. I would start with just a handful of signals first. We'll talk about that in a little bit. And usually, this I've seen in a lot of different places that people feel nothing is working for us. So we need to build our own thing. Unless you're a Google or an Apple or like a gi- ginormous company that has the ability to spend on that, might be a good idea, but otherwise, it's typically not where you want to go. So let me talk a little bit more about the user perspective, which has helped out in a couple of different scenarios. Uh, so if you were starting from the user perspective, this is again from Google's philosophy of the SRE model. There are four golden signals, and I call it shining light on where things need to improve. So you start with latency, described in percentiles. At the very base, you need to know what your customers are experiencing in terms of response times, expressed as a percentile number, not as an average. Then you have your error rates, and error rates in aggregate terms. For a very long time, the industry has been used to describing uptime versus downtime. I think we are way past that world now, where we are dealing with microservices and all systems that are always up. Errors need to be represented in terms of how many successful requests versus how many total requests, as opposed to we were up for 1 minute and down for 2 minutes. Then you have your traffic, just knowing what is happening in our system right now, what is our incoming traffic rate, and be able to historically look back and say, these are the patterns that we experience. And this is another level of maturity, knowing your saturation. How saturated are we? Given this is the traffic that is coming in, how much runway do we have left? Are we going to start hitting our error rate soon? Because that is what testing revealed in the lab, that above this point, this is where we hit errors. So shining a light on these four golden signals usually helps SRE dev and product teams figure out where they need to invest their time and energy. All right, and the last story, I'll try to wrap this one up very quickly. We have 6 more minutes, is that correct? Yes, I think so. Let's move.
Yes, you're right.
Yeah. All right. So this was around the time when uh, companies started realizing that most of their users were becoming mobile first. That at times, that more than 80% of their traffic was mobile and the rest was desktop. So the company got very involved with mobile performance testing, everything done, but again, blew up in production. So let me ask you a question. If we have 100 desktop users versus 100 mobile users in the chat, do you think they're equivalent to run the same load test for these two types of users, or are they completely different? In the interest of time, I'll move along a little more quickly. The answer is they are completely and totally different, because the resources that are, I'll give a quick high level differences. How mobile users hold on to resources on a server tends to be very different than how desktop users hold on to resources. Meaning, mobile users typically are on mobile networks, or they might not have the same processing power. So, for them to be able to, let's say, download just a PDF file, it might take on a 3G network, it might take much longer for a mobile user to download that file. But what that means is on the web server, on the app server, on the file server, on the database, connections are still staying open. And the memory is still being consumed by that one user, and those network connections are still open. So uh, the servers are going to feel that we are active a lot more when mobile users are hitting us, because while all those connections are open, CPU is being consumed, memory is being consumed, versus desktop users that come in and go out very quickly because they're typically on a broadband. Your desktop is typically plugged into an Ethernet cable, things like that. Mobile users also have a very different attention span. There are studies from Google. I have links in the notes. I'll probably post them in chat later. That shows that their expectations are way different. Also, mobile emulation in the lab is not very straightforward. How to emulate network latencies. So the main learning here was that mobile performance is not one number. There are many different things that make up front mobile and front end performance. How your different paints happen. Your first paint, first sign of life, contentful paint, meaningful paint when your screen fills up, your hero element, the most important thing that you're looking for. Uh, how long it takes for your site to become interactive. How long before your site is completely consistently interactive. All of these are different numbers. You can't just say my response time is 3 seconds. You need to be paying attention to all of these things. Google has also put out the Web Vitals framework, where it says the largest contentful paint should happen within 2.5 seconds. Your first input delay should be under 100 milliseconds, that people should be able to start typing, and the response should be seen on the scene instead of a lag. And your cumulative layout shift score should be under zero point 0.1.
Kushal, I will let you finish your talk, and for the question and answer, I would say you can continue in the Slack channel, please.
Yes, sounds good. I'm at the last slide, so let's wrap this up quickly. High level, what were my overall takeaways from all the failures that I'd seen overall? How do you ensure performance? Start with non-functional requirements. That's really where it all begins. Make sure that performance is treated as a feature, that it's not an afterthought. It's baked into the system as the system is being built. Validate that with lab tests to make sure that the non-functional requirements were met, but also line it up with what you're seeing with real world monitoring so that you know that there is parity between what you're seeing in the lab and the real world. And you tie it all up with feedback, and this is just a cycle or a loop that you keep getting better and better at. All right. Had to rush through at the end a little bit,
No,
but
no,
thank
no.
you for being
It's
an
perfectly
amazing
fine. But
audience.
I would like you to answer one question that I'm also curious about. So, I think the a good practice is to cover and care about performance not as an afterthought, but as early as possible in your development stage. So, what would you suggest for testers or teams? How
Mhm.
can they go about testing performance early in the sprints?
Yeah. More often than not, I've found it to be an organizational and more of a political problem than a
Mm-hmm.
technical skills and a issue problem. You
Okay.
need to get buy-in from the stakeholders, and if you're able to gather data to show, see, this is what we have been dealing with for the last few weeks or months or years. If you can work with your ops teams to get logs and characteristics, tickets, and be able to show, you know what, let's try out an experiment. How about I start introducing these sets of tests, and let's see if it has an impact on some of these numbers. Maybe we can bring our downtime, reduce it by so and so, or we can maybe improve our response time by this, or improve our ticket rate. If your stakeholders start supporting you, other things start falling into place.
Okay, Kaushal,
That
I need to take a